Picture this. It is a freezing cold morning in 2026, and you turn the key in your car, and the second that engine fires up, an absolutely deafening, ear-piercing, high-pitched scream erupts from under your hood. I am talking about a noise so violent, so metallic, so terrifying that your neighbors come out onto their porches in their bathrobes to stare at you. Dogs are barking, babies are crying. You are sitting in the driver's seat looking like the most irresponsible car owner in your entire zip code, and every single person on that street is now silently judging you, convinced you have destroyed your engine. You panic. You drive that screaming machine with your hands sweating on the steering wheel, 10 miles per hour all the way to the nearest dealership, praying the entire block doesn't fall out onto the pavement. And then the man in the polyester polo shirt gives you the diagnosis. He pulls out his iPad, and he says the words that have become a national epidemic in 2026. He tells you, with this fake sad face he practices in the mirror, that the bearings inside your water pump and your air conditioning compressor have catastrophically seized. He tells you the belt is dragging across locked metal components. He tells you that you need a new compressor, a new water pump, new tensioners, new idler pulleys, and of course, 6 hours of labor at $190 an hour. The final quote? $1,800. $1,800 in 2026 money, which, thanks to the inflation nobody wants to talk about, is basically your entire grocery budget for 2 months. And let me tell you something, my friend. That diagnosis is a lie. It is a beautifully constructed, financially devastating, scientifically fraudulent lie. The bearings in your Japanese-engineered water pump are perfectly fine. The compressor is fine. Nothing inside that engine is broken. The entire $1,800 nightmare comes down to a 1 millimeter shiny layer of dead rubber, and a $1 bar of soap from your bathroom is going to fix it in 3 seconds flat. The dealerships making billions off your squealing engine want you to think it's catastrophic internal metal failure. It isn't. It's basic rubber vitrification and lost friction coefficients. But, as always, I'm sharing this old-school diagnostic trick for educational purposes, because the auto parts lobby in this country has gotten so powerful, so well-funded, so deeply embedded in your local mechanics training manual that this kind of historical observation is starting to vanish from the internet entirely. Let me walk you through the actual engineering, because once you understand the architecture of what is spinning under your hood, you will never be lied to by a Stealership again. Your engine has one long, ribbed rubber belt called the Serpentine belt. They call it Serpentine because it snakes its way around your entire engine bay, wrapping around 6, 7, sometimes 8 different metal pulleys at the same time. That one single belt is the lifeline of basically every accessory on your vehicle. It drives the alternator, which charges your battery. It drives the water pump, which keeps your engine from melting itself into slag. It drives the power steering pump, which is why you can turn the wheel with one finger. It drives the air conditioning compressor, which keeps you alive in summer. It drives the tensioner pulley, which keeps tension on the entire system. One belt, one piece of reinforced rubber. The total cost of that belt at any auto parts store? $25. Maybe $30 if you go to a fancy brand. Now, here is what no Western mechanic will ever tell you. The belt is the cheapest part of the system, but the belt is also the part that fails first. And when it fails, it makes a noise that perfectly imitates the sound of catastrophic, expensive, big-ticket bearing failure. The bearings inside your alternator, your water pump, your compressor, they are sealed, heavy-duty steel bearings packed in synthetic grease, rated for 200,000 miles minimum on any Japanese-engineered platform. Toyota, Honda, Nissan, Mazda, Subaru, those manufacturers do not skimp on bearings. They overbuild them. They overbuild them so dramatically that engineers in Nagoya laugh when American mechanics claim a bearing seized at 60,000 miles. It didn't. What actually happened is much simpler and much cheaper. The belt got hot, the belt got old, the belt developed a glaze, and when a glazed belt slips against a smooth pulley, the friction coefficient collapses, and that high-frequency micro-slipping creates an acoustic resonance that sounds identical to a dying metal bearing. The two failure modes produce nearly identical sound signatures, and the entire Stealership industry has built a 6-figure business model around exploiting that confusion. Your ears cannot tell the difference between rubber slipping and metal grinding. You panic. You drive in. They quote you $1,800. They replace perfectly functional components. They throw your original parts in a bin. And they bill you. That is the entire scam in one paragraph. If you've ever felt that pit in your stomach when a mechanic walks out holding a clipboard, hit the like button right now. Because that algorithmic boost is the only thing keeping this channel from being buried by the auto parts lobby. And tell me in the comments if your car squeals on cold mornings and what a Stealership tried to charge you to fix it. I read every single comment, and I want to build a public archive of these quotes. Let's break down exactly how the $1,800 quote gets constructed, line by line, because once you see the math, you will get physically angry. A new aftermarket air conditioning compressor for an average 2018 sedan costs the shop about $320 wholesale. They will charge you $600. That is a markup of nearly 100% before a single tool comes out of the box. A new water pump? A wholesale cost to the shop around $80 to $120. They will charge you $250. The tensioner pulley, a $40 part, becomes a $120 line item. Now you stack the labor. They will quote you 6 hours, because removing an AC compressor requires evacuating the refrigerant, which they will charge you another $150 for, plus the cost of new refrigerant when they refill it, which on the new mandated R1234YF systems can run $200 by itself. Suddenly you are looking at $600 in parts, $350 in refrigerant work, and $1,100 in labor, and you have not even touched the actual problem. The actual problem is a piece of rubber that costs less than your morning coffee. The technician working on your car probably knows this. The service writer at the front desk absolutely knows this. But the dealership business model in 2026 does not survive on $25 belt replacements. It survives on $1,800 phantom failures. And here is the part that should make your blood boil. They are betting on your auditory panic. They are betting that the horrible noise terrified you so badly that you will sign anything just to make it stop. They train their writers on that panic. They have scripts. They have psychological flowcharts for upselling a scared customer. This is not a conspiracy theory. This is the documented operational playbook of multiple national service chains, and you can find the leaked training materials online if you know where to look. Auditory extortion. That is what this is. They are weaponizing the noise your car makes to bypass your rational brain and access your wallet directly. Now let's talk about the actual science, because once you understand rubber vitrification, you will never panic over a squealing belt again. Your Serpentine belt is made of layered synthetic rubber, usually EPDM or a similar polymer, reinforced with woven cords. When that belt is brand new, the ribbed underside has a slightly textured, almost matte surface. That texture is what grips the smooth metal pulleys. The friction coefficient between fresh rubber and polished steel is high, somewhere around 0.7 to 0.9, which is more than enough to transfer 30 or 40 horsepower of accessory load without slipping. But the engine bay is a hostile environment. Temperatures regularly hit 220 degrees Fahrenheit right next to the exhaust manifold. Over thousands of heat cycles, the plasticizers and oils that keep the rubber soft slowly evaporate out. The surface of the belt undergoes a process called vitrification, which is a fancy engineering term for becoming glass-like. The textured rubber surface flattens out, polishes itself smooth against the pulleys, and develops a shiny, hardened layer about 1 millimeter thick. That shiny layer is the glazing. Glazed rubber has a friction coefficient closer to 0.2, which is roughly the same as ice on steel. The belt cannot grip anymore. It microslips thousands of times per second, and that microslipping is what creates the high-frequency squeal that sounds like dying bearings. It is pure surface chemistry. Now here is where the soap comes in, and this is where Japanese master mechanics have been laughing at American dealerships for 40 years. A standard bar of soap, the cheapest, dumbest $1 bar of soap you can find at any drugstore, contains glycerin, tallow fats, sodium hydroxide residues, and various lipid compounds. When you touch that bar of soap to a spinning glazed belt, those compounds melt instantly from the friction heat and deposit a microscopic layer of conditioning agent onto the rubber surface. The lipids penetrate the vitrified layer, restore surface softness, and dramatically increase the friction coefficient back up towards 0.6 or 0.7. The belt grips again. The slipping stops. The squeal disappears in less than 3 seconds. It is not magic. It is industrial chemistry. The same chemistry that auto parts stores sell back to you in a spray can label belt dressing for $19. The soap does the exact same job for $1. Let me walk you through how to do this safely, because we are about to work near a running engine, and the rules here are not optional. First, you pop your hood, and you locate the Serpentine belt. It is the long, black ribbed belt snaking across the front of the engine. You will see it wrapped around multiple metal pulleys. Identify the longest straight section of belt, ideally on the inside rib side, where it travels between 2 pulleys without anything else in the way. Now, before you do anything else, you take off any loose clothing. No long sleeves, no hoodie strings, No necklaces, no bracelets. Tie back long hair, roll up your sleeves tight. If a loose thread catches a spinning pulley, it will pull your entire hand into the engine in a fraction of a second. There is no recovering from that. With the engine running at idle, you take an ordinary dry bar of soap, a bar of ivory, dove, anything cheap and white. You hold it firmly in your dominant hand, and you carefully extend it toward the inside ribbed surface of the moving belt. You do not touch the pulleys. You do not touch the tensioner. You only touch the flat-ribbed backside of the spinning belt for no more than 3 seconds. You will see a fine white residue transfer onto the belt. You will hear the squeal change pitch and then vanish. Pull your hand back immediately, slowly, away from the engine. Step back, wait 30 seconds. Listen, the noise should be completely gone. If it is not, you can repeat once, but only once. If the squeal persists after 2 applications, the belt is too far gone and physically needs replacement. A solid stick of antiperspirant deodorant works identically. Same fats, same glycerin, same result. One final warning, and I need you to hear me on this. This is a diagnostic trick, not a permanent repair. If your belt is visibly cracked, has chunks missing from the ribs, or is fraying at the edges, you need to replace it immediately, because a belt that fails completely at highway speed will strand you and overheat your engine in minutes. The soap fix tells you the bearings are fine and buys you time to drive home or to an honest mechanic. Never put your hand near a moving engine if you are tired, distracted, or unsure. If you are not comfortable, do not do this. Subscribe and hit the bell before the auto parts lobby makes it illegal to talk about belt dressing, because they are coming for content exactly like this one, and the more of us who know the truth, the harder it is for them to bear.